scientists, welcome to Alan IntelliBrain. In this video, we will learn about diagonals and the sum of all the exterior angles of a polygon by performing the Intelli activity on deriving the formula for finding the number of diagonals in a polygon and finding the sum of all the exterior angles of a polygon. If the sides of the polygon are produced in an order. From your Intelli SMART Box, take out the polygon cards, exterior angle cards, geometry kit and the marker pen. Keep the polygon cards on a flat surface and observe them. We have 2 polygon cards for each shape. Let's pick a pentagon card B and keep the rest aside. Now, mark each vertex as A, B, C, D and E using the marker. Now, we are going to find the number of diagonals in a pentagon. Place the ruler on a flat surface. Let's start with vertex A. Now look here. As you can see, vertex A is adjacent to vertex B and E. So, we will skip vertex B and E and draw a straight line to join vertex A and C. Similarly, A and D. We have drawn 2 diagonals from vertex A. Now, let's repeat this for vertex B. Adjacent vertices to vertex B are A and C. So, leave them. Draw diagonals BE and BD. Now, we have drawn 2 more diagonals. Now, let's take vertex C. Adjacent vertices to vertex C are B and D. So, leave them. Now, we can see that we have already drawn the diagonal from vertex C to A. Therefore, we will not count it. So, we will only draw diagonal from vertex C to E. Now, we have one more diagonal. Let's take vertex D. Its adjacent vertices are C and E. So, leave them. Let's look at DA and DB. We have already drawn them. Similarly, look at vertex E. Its adjacent vertices are A and D. So, leave them. Again, already diagonal EB and EC are drawn. Let's now count the number of diagonals that can be drawn in the pentagon. AC or CA, AD or DA, BD or DB, BE or EB and CE or EC. We have a total of 5 diagonals. Note that in a pentagon, the number of vertices is 5. From every vertex, we can draw 2 diagonals. Number of possible diagonals, including the repetitive diagonals, is 10. But each diagonal will be counted twice if we include the repetitive diagonals. Therefore, the number of diagonals is 5. Now, let's find the number of diagonals for a hexagon. Place the hexagon card A and the marker on a table. Mark each vertex as A, B, C, D, E and F using the marker. Now look at the vertex A. Adjacent vertices are B and F. So leave them. From vertex A, we can draw the diagonal AC using the ruler, AD and AE. Now let's take vertex B. Its adjacent vertices are A and C. So leave them. From vertex B, we can draw diagonals BF, BE and BD. Now let's look at vertex C. Its adjacent vertices are B and D. From vertex C, we can draw diagonals CF and CE. But we cannot draw diagonal CA as we have already drawn it. Now let's move to vertex D. Its adjacent vertices are C and E. From vertex D, we can only draw diagonal DF as we have already drawn the diagonal DB and DA. Now let's move to vertex E. Its adjacent vertices are F and D. Note that from vertex E, we have already drawn the diagonals EC, EB and EA. Similarly, look at vertex F. Its adjacent vertices are A and E. From vertex F, we have already drawn the diagonals FB, FC and FD. Now let's count the number of diagonals that can be drawn in a hexagon, and that are AC or CA, AD or DA, AE or EA, BD or DB, BE or EB, BF or FB, CE or EC, CF or FC and DF or FD. So we have a total of 9 diagonals. Note that in a hexagon, number of vertices is 6. From every vertex, we can draw 3 diagonals. Number of possible diagonals including the repetitive diagonals is 18. But each diagonal will be counted twice if we include the repetitive diagonals. Therefore, the number of diagonals is 9. So now we have learned to find the number of diagonals of a hexagon and a pentagon without using the formula. Now look at our observations. The number of sides in a pentagon is 5. The number of diagonals that can be drawn from each vertex is 5 multiplied by 2, or we can also write it as 5 multiplied by bracket 5 minus 3, that is equal to 10. As each diagonal is being counted twice, so we divide the count by 2, or we can also write it as 5 multiplied by bracket 5 minus 3 whole bracket divided by 2, that is equal to 5. Similarly, in a hexagon, the number of sides is 6. The number of diagonals that can be drawn from each vertex is equal to 6 multiplied by 3, or we can also write it as 6 multiplied by bracket 6 minus 3, that is equal to 18. So, the number of diagonals in a hexagon is 18 divided by 2, that is equal to 9. As each diagonal is being counted twice, therefore we divide the count by 2. We can also write it as 6 multiplied by bracket 6 minus 3 whole bracket divided by 2, that is equal to 9. Therefore, we can say that if the number of sides is n, then the number of diagonals that can be drawn from each vertex, including the repetitive ones, will be n multiplied by bracket n minus 3, while the number of diagonals in an n-sided polygon will be n multiplied by bracket n minus 3 whole bracket divided by 2. Therefore, the formula for calculating the number of diagonals in an n-sided polygon will be n multiplied by bracket n minus 3 whole bracket divided by 2. Wonderful! We have successfully learned to find the number of diagonals without using the formula and also deduce the formula from our observations. Now let's learn to find the sum of all the exterior angles of a polygon. Place the exterior angle cards, marker and a pair of scissors on a table. We have picked the octagon exterior angle card. Observe its internal angles marked as capital A, capital B, capital C, capital D, capital E, capital F, capital G and capital H. Now look at the 8 exterior angles marked yellow adjacent to each interior angle. Name the corresponding exterior angles marked as small a, small b, small c, small d, small e, small f, small g and small h respectively. Make sure to mark them inside the yellow colored parts as shown here. Now use a pair of scissors to carefully cut out the yellow colored part of each exterior angle and place them one by one on a table. Arrange the cut pieces to form a circle. Like this. As we know, the angle around the center of a circle is equals to 360 degrees. Therefore, the sum of all the exterior angles of the octagon will be equal to 360 degrees. Now you can try yourself and find the sum of the exterior angles as well as the number of diagonals for every polygon. After doing this activity, you will have gained the expertise in the following concepts. Understanding and deriving the formula for finding the number of diagonals in different polygons. Finding the sum of all the exterior angles of a polygon when the sides of a polygon are produced in an order. Visualize maths with Alan Intelli and fall in love with learning.